Hi guys, today we are going to talk about the next generation science standards. What are the NGSS standards? According to the NGSS website, there are K to 12 science content standards. Standards set the expectations for what students should know and be able to do. The NGSS were developed by states to improve science education for all students. A goal for developing the NGSS was to create a set of research-based, up-to-date K-12 science standards. These standards give local educators the flexibility to design classroom learning experiences that stimulate students' interest in science and prepare them for the real world. According to the California Academy of Sciences, the philosophy of the NGSS draws on extensive evidence-based research in the science education field. The outcomes of all this research were to distill to create a framework of K-12 science education, which lays out the three-dimensional structure underlying the NGSS. Why are the NGSS important? It focuses more on student performance, deeper understanding, and integrates science and engineering. It also prepares students for the future in jobs, college, or career.
All right, I will attempt to translate some of the bigger concepts that will help you better understand the lingo that's used in the next generation science standards. The overarching theme of the NGSS is three-dimensional learning. Three-dimensional learning is what students experience in classrooms using NGSS. Lessons and units aligned to the standards should be three-dimensional. That is, they should allow students to actively engage with the practices and apply the cross-cutting concepts to deepen their understanding of core ideas across science disciplines. The three dimensions are the three standards of knowledge and skills that students should be able to use to explain phenomena and design solutions to problems. They are as follows. Dimension 1, Science and Engineering Practices. The practices are what students do to make sense of phenomenon. They are both a set of skills and a set of knowledge to be internalized. The SEPs reflect the major practices that scientists and engineers use to investigate the world and design and build systems. Dimension 2, Cross-cutting concepts. These are concepts that hold true across the natural and engineered world. Students can use them to make connections across seemingly disparate disciplines or situations, connect new learning to prior experiences, and more deeply engage with materials across the other dimensions. Dimension 3, Disciplinary core ideas. The fundamental ideas that are necessary for understanding a given science discipline. The core ideas all have broad importance within or across science of engineering or engineering disciplines. Provide a key tool for understanding or investigating complex ideas and solving problems. They relate to societal or personal concerns and can be taught over multiple grade levels at progressive levels of depth and complexity. And with the powers of the three dimensions combined, we are given our performance expectations. The NGSS is not a set of daily standards, but a set of expectations for what students should be able to do by the end of instruction. The performance expectations set the learning goals for students, but do not describe how students get there. And then this is sort of like the little code that you will encounter if you are searching on the standards website, and it's sort of grouped by first the grade level or band, so this one is middle school, and then the domain is physical science, and then the core idea is core idea 4 and dash 2. So that's if you're looking up different standards, this is kind of what you will encounter searching on the NGSS website.
And I am looking at the methodology in the NGSS. Students in elementary school are building their understanding of science in these 4 areas: physical sciences, life sciences, earth and space sciences, and engineering, technology, and application of science. In the earlier grades, students begin to see patterns. They also begin to answer questions about the world around them. I will look at the kindergarten standards as an example. The standards are arranged into bundles. I found an example bundle for kindergarten on the Next Gen Science website. NGSS defines bundling as grouping concepts from multiple PEs in lessons or units. Then students can work on developing competency in these multiple performance expectations in a consistent manner. In kindergarten, students will work to answer these questions during the year. Bundle 1. What do plants and animals need to meet their needs and survive within environments? Bundle 2. Can changes in weather patterns be observed over the course of the year? Can weather influence the ability of plants and animals to meet their needs in their environment? And Bundle 3. How do pushes and pulls affect the motion of an object? These 3 bundles were built to focus on patterns in the natural and designed worlds. This idea can be seen in physical, life, and earth and space sciences, and also engineering. Kindergarten students are beginning to understand the cross-cutting concepts of patterns in the world. Students are observing their local weather and looking for patterns over time. These patterns can be seen in the change in the weather between seasons. Students are also seeing the relationship between cause and effect. There is an emphasis on asking questions, using observations and models, analyzing data, and carrying out investigations. We also have some additional interesting resources, videos that can be found, links here.
All right, and there's our reference page. Thank you so much.
Bye.
All
Bye.
right.